This is 5.4b, binomial probability distribution. So last time we talked about questions like this one. Example 1, 90% of a company's calculators are deemed good. 10% are deemed bad. If we send 10 calculators to an inspector, find the probability of getting exactly a good or exactly a bad. So the key thing is up until this point, we've been getting asked for exactly some amount. Exactly this, exactly that. Okay, so we could actually do this. We still need NPQ, and we set it up. N is how many do we have total? 10 calculators. P is the probability of success. We're looking for good, so a success is 90% or 0.9, written in decimal form. That means failure must be 0.1, 10%. Okay, so I want the probability of 8 good. So x equals 8. So we have the probability of success raised to the power of x times the probability of failure raised to the power of n minus x, which is 2, 10 minus 8, times ncx. And we just type that in our calculators. 0.9 to the 8th times 0.1 squared times 10c8, round to the 10th of a percent, and I get 19.4%. Okay? And then one thing to recognize with this is you really need to pay attention to the question. This seems like the exact same question, but it's a very different answer because now we are looking for bad. So make sure you're really careful when defining your success versus your failure. So we still have 10 calculators. This time my success is 0.1 and my failure is 0.9. And you'll see how drastically this changes. So if I have the probability of 8 bad, it's 0.1 to the 8th times 0.9 to the 10 minus 8, which is 2, times 10c8. It seems very similar. Just flip those two. But this is going to give you a vastly different answer. I mean, if you type it in, you get, even converting to percentage, you get 0.00004%. So you can see, changing the success and not paying attention to what is a success versus a failure is a big deal. You're getting either 19.4% as your answer or 0.00004%. Very different things, okay? So pay attention to that. But that's what we've been doing. It's just one thing. We get one answer, done. Okay, that's not going to be the case anymore. So now we have at least and at most. Okay, so with at least, that means if I had a question like at least 5 good, that means I need 5, 6, 7, 8, ... wherever the highest number goes. So in this question right here, if it was at least 8 good, we'd have 8, 9, and 10. We'd have to find 3 probabilities to be able to get to this answer. At most is that value at or less. So at most 5 good, that means we would be finding 5, 4, 3, 2, 1, and 0. Don't forget, 0 is the bottom end. Okay, you can't ever have negative of these. So 0 is the end. And don't forget about 0. So many people forget about 0. Okay, so let's do a couple questions, and then we'll call it good. So find the probability. We tossed 5 coins. Find the probability of getting at least 3 tails. All right, so let's define our N, P, and Q. So N is 10. Nope. N is 5 coins. P is our success, so tails is 1/2. Q is our failure, which happens to also be 1/2. This is kind of the easier type of question. But at least 3. So that means we need 3 and 4 and 5. At least means that value or more. So 3, 4, and 5. 5 is the largest it gets. And we actually have to find all 3 of those. Okay, so find 3 first. So it's 1/2 cubed times 1/2 to the n minus x, so squared, times 5c3. Okay? So if you get that, you get 31.25%. Rounding a little bit. Actually, I think that one's exact. Okay? Then we have to find 4. It's 1/2 to the 4th times 1/2 to the n minus x, so it's 1 times 5c4. So that's 15.625%. And then finally we get to the 5th. 1/2 to the 5th times 1/2 to the 0. Anything raised to the 0 power is just 1. Don't forget that. Times 5c5. And so that's 3.125%. To get our final answer, we add them up. Add them all up. So we type these all into our calculators, we add them up, and it actually ends up being exactly 50%. There's a 50% chance that if you toss 5 coins, you will get at least 3 tails. Okay. Example 3, same idea. We roll 6 dice. Find the probability of getting at most 2 6s. So that's counting down. 2, 1, 0. At most 6. We also need NPQ. So N is 6. P is we're getting a 6. That's our success. So it's a 1/6 chance. Q is the rest, 5/6. Okay. So I have 3 probabilities to find. It's not always going to be 3 in these 2 examples. It happened to be. Okay, so probability of getting 2 is 1/6 squared times 5/6 to the 4th times 6c2, which is about 20%. So we'll do 20.1%. I'm rounding, that's fine. Probability of 3. Nope, sorry, that's incorrect. I should be counting down, so it's probability of 1. So 1/6 to the 1st times 5/6 to the 5th times 6c1, and you get 40.2%. And finally, probability of 0. No 6s, so it's 2 6s, 1 6, and now no 6s. 1/6 to the 0, remember that's just 1. 5/6 to the 6th times 6c0, and you get 33.5%. And we add them up, and we get the final answer of 93.8%, which is pretty big. Okay, if you rolled 6 dice, you have almost a 94% chance that you would get at most 2 6s. Getting more than 2 6s is very, very slim chance, actually, with 6 die rolls. Okay. So I'm not going to go into too much because we'll do some more of these examples in class. But notice, it's literally what we've been doing multiple times, and then we just add them up to get to our final answer. Okay, so you have a 3-sentence summary to write.